The diameter of a circle is a chord that passes through the center point. A chord is a line segment that has two endpoints on the outer edge of the circle. The radius of a circle is half the diameter of the circle.
In this picture, Zach and Mikey are representing Theorem 6.5. Theorem 6.5 states that in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So this arc created by Zach is congruent to the arc made by Mikey if and only if the chords Zach and Mikey are congruent. In this picture, Smarty and I are showing Theorem 6.6, which states that if one chord is a perpendicular bisector of another chord, then the first chord is a diameter. If Smarty is a perpendicular bisector of me, then Smarty is the diameter of the circle.
Theorem 6.7 states if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. If Smarty is a diameter and Smarty and Hyun are perpendicular, then Hyun's torso is congruent to Hyun's legs, and the arc created by Hyun's torso is congruent to the arc created by Hyun's legs.
In this picture represented by Smarty and Hyun, Theorem 6.8 says in the same circle or in two congruent circles, two chords are congruent if and only if they are equal distant from the center. Smarty is congruent to Hyun if and only if Hyun's arm is touching the center is congruent to Smarty's arm touching the center.
In this picture, Hyun and Smarty represent Theorem 6.16, Segments and Chords Theorem. It states that if two chords intersect in the interior of a circle, then the product of the length of the segments of one chord is equal to the product of the lengths of the segments of the other chord. This means that Smarty's legs times her full body equals Hyun's legs times her full body.
In this picture, Zach and I are secants that meet at a common endpoint outside the circle, using Theorem 6.17, which says if two secants share a common endpoint outside a circle, then the part outside the circle multiplied by the whole secant will equal the part of the other secant outside the circle multiplied by its whole length. Using this theorem, we can prove that my lower legs multiplied by my whole body equals Zach's lower legs multiplied by his whole body.
In this picture, Mikey represents Theorem 6.18, Segments to Secants and Tangents Theorem. If a secant segment, which is his body, and a tangent segment, which is his arm, share an endpoint outside the circle, which is his armpit, then his arm squared equals his upper body times his legs. In this picture, Hyun is standing inside the circle. The circumference of the circle, which is Theorem 6.19, is circumference equals pi times diameter, or circumference equals 2 pi radius. The arc length corollary states that in a circle, the ratio of the length of a given arc to the circumference is equal to the ratio of the measure of the arc to 360 degrees. For example, if the measure of the pie that I haven't eaten is 260 degrees and the arc made by the pie I haven't eaten is 81.64 inches, then we can set up a ratio to find the circumference of the entire pie. 260 over 360 is equal to 81.64 over x. We can cross multiply to find our circumference, which ends up being 113.04 inches. Theorem 6.22, surface area of a sphere, states that the surface area S of a sphere is S equals 4 pi r squared, where r is the radius of the sphere.
Theorem 6.23, the volume of a sphere, states the volume V of a sphere is V equals 4/3 pi r cubed, where r is the radius of the sphere.